Hi, my name is Lynn, and in this video, I'll be walking you through my poster on latent inhibition in younger and older children. Latent inhibition refers to the slower learning of a cue outcome relationship following repeated presentation of that cue without an outcome, and it has been found that younger but not older children demonstrate it. However, the task used was too easy to solve for older children and may have resulted in a floor effect. For example, if we take a look at this figure, where the x-axis is the age and the y-axis or the mean trials to criterion, we can clearly see the floor effect from age 7 and above. This study, therefore, aims to investigate the relationship between age and latent inhibition with a task that is not susceptible to floor effects. An example would be the letter prediction task by Granger et al. This task begins with a pre-exposure stage where participants were presented with a series of letters and were asked to say them out loud. At test, participants were presented with a series of letters again, but this time were told to press the spacebar whenever they saw X or think X will appear. If we look at this design table, S was the pre-exposed cue as it was initially presented by itself before being paired with X, while H was the non-pre-exposed cue as it was only introduced at test and was always paired with X. Therefore, it was expected that participants would learn the SX association slower than the HX association, and this was exactly what was found by Granger et al. As seen from this figure. Here, the x-axis is the trial presented and the y-axis was the reaction time for both cues, and the reaction time for pre-exposed cues was greater than the non-pre-exposed cues. Hence, we use this task to determine if we can find latent inhibition in children ages 4 to 5, 6 to 9, and 10 to 14, and recruited our participants from Summer Scientist Week. For the first three figures from the left, trials presented were the x-axis, and reaction time for both cues was the y-axis, and we can see that across all age groups, the decrease in reaction times were comparable. When a Bayesian paired samples t-test between the pre-exposed and non-pre-exposed reaction time was conducted, the results showed a strong latent inhibition effect in 10 to 14-year-old children and a weak effect in children ages 4 to 5 and 6 to 9. A latent inhibition score was then calculated by subtracting the non-pre-exposed cue's reaction time from the pre-exposed cue's reaction time, and this serves as an index of magnitude of latent inhibition. A scatter plot with age as the x-axis and magnitude of latent inhibition as the y-axis was plotted, and it appears that as children grow older, the effect of latent inhibition gets stronger. However, the Bayesian linear regression only showed a weak positive relationship between age and latent inhibition. In conclusion, the findings of this study showed a strong latent inhibition effect in older children and a weaker effect in younger children. The Bayesian values from the analysis suggested that more participants was needed, and thus our future study will be to recruit more participants to balance the current sample.